Welcome to the replay of our virtual Green Drinks March 2021, a practical guide to heat pumps. For this edition, we welcomed Matthew Eglin from RightWheel, Région Pro, heat pump advocate, and Aaron Thornell from Co-Energy Co-op. The March edition. I want to thank you so much for joining us. It's going to be an exciting edition talking about heat pumps. It's a technology that I've been interested in myself for a couple of years now, and to learn more. And a lot of our members are working in that space. We've got a couple of our members on today that will be able to talk a little bit after the presentations about some of the work they're doing in the space. And you know, it's an exciting technology to learn a little bit more about what's going on. So for those of you who don't know me, I am Nick Hebb with SmartNet Alliance, and the Alliance is a group of businesses and organizations who collaborate on projects and initiatives to accelerate Canada's transition to a sustainable economy. For more information on SNA, please consult our website, and I'll share some links into chat, as well as our LinkedIn, Facebook, social media stuff. So you'll be able to find out more details about our members, and we have recently launched some business courses, which you can find on our resource page. Be sure to check out the membership page while you're there, and I'll put that link into the website. For anybody who didn't get a chance to sign up to the newsletter on the Eventbrite, I definitely invite you to do that. And we put out a monthly newsletter with a lot of good stuff going on, and keep you posted on all the great virtual events. So for those of you who are not familiar with Green Drinks, it is an international event. It is still going. Most of them are on Zoom now, and it happens in about 500 different countries, 20 different chapters in Ontario alone. It has existed in the Ottawa market for about 10 years now, and for the past 5 or so years, SmartNet Alliance has been hosting the event. And our normal location is the Fox and Feather, but as I'm looking at the participants, we just hit 100. So congratulations, everybody. That's a bit of a first on our virtual Green Drinks. And we definitely wouldn't have fit into the Fox and Feather with 100 of us. It would have been a bit too tight even before COVID. So that's great. So we'll get rolling on heat pumps here. So heat pumps are a vital technology in the fight against climate change, and they have efficiency levels of up to 400%. So I'm excited to hear about some of that. So, you know, they are the very foundation of a 100% renewable energy system, and they will be very vital in the coming years as we make the switch from carbon to heat and cool our homes. So buildings use more than 1/3 of the world's energy, and most of that is for heating and cooling. So most figures show that we can cut the usage in half, and if not higher, with the mass adoption of heat pumps. So today's presentations during our virtual Green Drinks are designed to bring new solutions to attendees and to promote further discussions around concrete actions we can all take to reduce emissions. So that's great. So I want to bring in our first speaker, and let me grab my bios for him, and we'll get that rolling. Okay, so longtime Green Drinks advocate Matthew Eglin is going to come up first, and he's a technology consultant and president of RightWheel Inc. RightWheel works to reduce the emissions for their clients with a focus on transportation and emission awareness. Matthew is also a climate reality leader. He graduated the LA 2018 edition and is working on to hashtag Stop Burning Stuff. I love that. Matthew has served on the board of the EVCO for the last 4 years and has recently moved to a 19th century house in Picton, where he's working on updating the house and its systems. So let's bring in Matthew Eglin. Thanks so much for joining us, and you can share your screen and get rolling.
Great. So let's share that. Did that come up?
Yeah, that's looking good. I just wanted to remind everybody to throw your questions into chat as we roll through. We'll let Matt kind of go through his presentation, and then I'll quarterback the questions through to Matt after chat. So please go ahead and use chat for your questions. Over to you, Matt.
Great, thanks, Nick. So in moving to the new house, one of the things we've been doing is looking at ways we can improve it, and heat pumps came up pretty early as a technology. And I wanted to share this information that I found, the practical information I found, with you guys, and talk about why heat pumps matter and why you should own one, or maybe more. So let's just go forward and what we're going to talk about. So I'm going to talk about household heat pumps. Rajan's going to talk about a hybrid heat pump, which is a really good solution for today. And Aaron's going to talk about heat pumps in apartment buildings, which is an interesting thing that Co-Energy is looking into. Let's talk about what is a heat pump. Well, to put it simply, a heat pump is just something that moves heat from a cold place to a warm place. And the simplest example is your fridge. Like EVs, like a lot of the stuff we're looking at now, this is ancient technology. It comes over 130, 140 years old. It's the refrigeration cycle, but we're just talking about using it in a more entertaining and ecologically sound way. The key thing to remember about the cycle where we move heat from the cold side to the warm side is it takes a lot less energy to move the heat than it does to make it. So taking the heat from the cold side and putting it onto the warm side and doing the work to make that happen is far more efficient than actually just making the heat. Heat pumps come in all shapes and sizes. We've talked a lot in Green Drinks about whole house solutions like the Mitsubishi Zuba system and similar systems. We're not going to talk about those today. They're expensive, and I think they're well understood by most people. What I do want to talk about, though, is the places you can find heat pumps that are not so obvious. One of them is one of our electric vehicles, the e-Golf. Our Tesla doesn't have one, but new Teslas now also have a heat pump. In our clothes dryers, in my living room, you can see the heat pump up there, and in my basement in the hot water system. These are not the things we normally talk about. Why are heat pumps important? I mentioned this earlier. It's this idea of making better use of the energy. And let's compare them with EVs. So we look at a gas car and a hydrogen fuel cell car and a battery electric vehicle. An EV allows you to take 1 unit of energy and do 4 to 5 times the amount of travel. And that's why battery electric vehicles are so good for the environment. It's not just that they're using electricity, it's that they're making better use of the available energy. They're far, far more efficient. Heat pumps are kind of the same. So let's take a look at the heating systems I have in my house. We have methane, natural gas, which is a really good furnace. Is about 95% efficient when it's new. A bad one's probably around 80% efficient. Electric baseboards are sort of by definition 100% efficient because the heat that goes in comes into the room. But a heat pump is far more efficient than that. It's at least 300% efficient and can be as much as 500% efficient. So again, heat pumps take 1 unit of energy and do 3 to 5 times the amount of work with it. So it's a really good thing for making sure that when we electrify everything, that we don't overload. We make the best use of scarce electricity during the winter, particularly. So let's talk about heat pumps for your home. Let's first talk about clothes dryers. Now, a lot of my friends were kind of surprised when we bought heat pump clothes dryers. We actually have 2 of them. How do you use a heat pump to dry clothes? It seems a little counterintuitive. It's actually a closed cycle, and you can see in the diagram here. There's a warm. Can you see my mouse, by the way? Does that show?
I don't see it, but we definitely see the cycle going around.
Okay, so right? you see the red arrows coming out of the warm side of the heat.
Yeah, that's great.
Yeah. So that's the red. The red hatches here is the warm side of the heat pump, and at the bottom here we have the cold side. So what's happening is the heat is, we're adding heat and putting it into the drum just like a conventional dryer, but then we take that warm, wet air and we put it through a cooler, and that does 2 things. It takes the moisture out of the air because it condensates out, and in the process gives up some energy. And we cool the air down to do that. And that energy, which we've recovered from the condensation of the water in the clothes and from the cooling of the air, then gets used to warm the air going into the drum. So this is essentially a closed cycle. So it's incredibly efficient and very good at getting rid of moisture. There are 2 types that are commonly available. There's this type, which is a closed cycle system. And there's a hybrid one, which actually has a supplemental electric heater just in the corner here. And they're less efficient, but they're more available in the big sizes. So let's look at the 2 heat pump dryers we own. This is the one here in this house. This is a 460 kilowatt hour per year device, according to EnerGuide. And it replaced a device that was 978 kilowatt hours. So it's about a 53% improvement. For us, it's a bit more than that because it's ventless, although there is some cooling air that comes out the back. So the waste heat that's associated with this 460 kilowatts is actually coming back into the house. And in the winter, it warms that corner of the house, which is very good for us. It's in a good spot that needs to be warmed. It's not so good in the summer because there is waste heat, but we have our patented solar wind-driven clothes dryer, a clothesline outside that we'll use then. So unless you can dry outside, I don't think this is a perfect solution, but it's a really good solution if you do. It only needs a 20 amp breaker, and if you've got issues with panel capacity that you want to use, for example, if you want to buy an EV and you're short of panel capacity, you can reduce the breaker from 30 amps to 20. And this one is the most efficient full-size heat pump dryer on the market. So I call that the first generation heat pump dryer. In our house in Ottawa, we installed this system. We had an apartment-sized space for the washer and dryer, and we've gone with Samsung. This one is amazing. This one, again, replaced a dryer that was using about 900 kilowatt hours a year. It uses 145, an 84% reduction in energy use. And this one generates almost no waste heat. So you could use this in the middle of the summer, and it's it won't warm the house. You're not putting extra load in your air conditioning. And it has a tiny breaker requirement of 15 amps. It needs 240 still, but it's only 15 amps. This is the future. This is really an incredible device. Works really well. The cycle times on both these dryers are the same as the washer, so about an hour. And we've had really good success with them. They work really, really well. So the costs for those, the Samsung was around $1,000 when we got a 25 with a 25% Energy Star rebate. Shipping and tax taking it to about $1,000, so $998. So we basically paid for the tax and the shipping. And the Whirlpool came out to about $1,400. The Samsung will pay for itself in about 2 to 3 years, just in straight energy reductions, and the Whirlpool will be closer to 10 because it's less efficient. There are federal rebates for Energy Star appliances that are good until at least the end of March. So if you're looking for any appliances at the moment, find one with a rebate. You need to make sure your retailer is taking part and has a rebate to give you. And for the record, we used FW Black in Kingston and Rona in Ottawa for these devices. It was a really good deal. This is my favorite. I love this one. This is my heat pump hot water heater. This should be mandated in all houses as part of the building code. They're incredible. So this pulls heat from the basement and puts it into my hot water, and it has an incredibly low cost of running. It's around 104. This is the American one. It's around $104 a year, and that's about what we see. It's great in summer because it's giving me extra AC. In the winter, you can see this is an uninsulated stone basement, and that's going to get fixed eventually. This is actually accidentally conditioned. And so I use this heat pump to actually reduce the temperature slightly in the basement, which is no big deal because it's not occupied. And it replaces my dehumidifier that was in the basement. So the basement is now incredibly dry and about 2 to 3 degrees cooler, which is no problem for us. So if you're buying one of these, you have to be a little bit careful about where it's going to fit, and you need to have enough space to accommodate the airflow that it needs. It needs around, I forget the number. It needs a fairly substantial space, or you need to vent it to other spaces in the house. You need to be careful about where you put the cold. The tank was about $2,200 and they're available from Home Depot. The installation was about $1,000, and that was including removing a gas water heater, capping off the gas, doing some changes around that, and putting in a tempering valve. The tempering valve is a mixing valve that keeps the hot water at a constant temperature and allows me to vary the temperature of the tank during the day, which I use for economy. We calculated this about a 2 to 4 year payback. The cost to replace an existing electric tank would be very low because it's essentially plug and play. You just basically use the same wiring and hook it up. There are other systems that are available. They're all a bit more expensive. There's some that have outdoor units. There's a video playlist which I've posted to, to the Facebook group. And there's Matt Reisinger of the Build Show has done a very good video, and it's on that playlist. So that's something you should look at if you're interested in this as a general thing. The only significant downside we've found is noise. The system is a little bit noisier than a gas-powered tank. So you can hear it about the same in the living room, but it runs a lot longer and became a bit irritating. So what we've done is we've actually put some sound insulation between the main floor and the basement to reduce that, and that's made it quite acceptable. So that is something you have to consider, though. Depends on your installation. This is the performance that we get. This is the application that comes with it, and you can do all sorts of things with the applications. I have it scheduled so it doesn't run at all when the electricity is the most expensive, and I have it at a low temperature during the day and a high temperature at night to make the best use of the available electricity. And you can see here that we're using an average of about 3.5 kilowatt hours per day, which if you do the math works out to be about $130 a year, which is about 104 US, which is what they were getting. So the claims of the savings are quite good, quite accurate. The one thing I will say is the software is a bit iffy. Doesn't always work the way you want it to. Basically, the application will tell you lies and the tank will tell you lies. You need to go down and check the control panel to make sure it's doing what you think it should be doing. I have found now that the schedule that I have set is stable and working quite well, though. But it did take me a few attempts to get it right. Okay, and the last technology we installed was a mini split. And the space I'm in now, actually the living room, which is just outside, was a cold spot in the house, and it wasn't. There were no vents in that space from the central furnace system, and it was heated with a natural gas fire stove, and we were running it a lot. So we decided to put in a heat pump, and there's also a space above me that's sort of like a granny suite kind of thing, which is also a bit cold. So what we ended up doing was putting in a 2-head mini split system, and that has been a phenomenal success. It's a great thing for old houses and where you've got cold spots, or an old house where you have a hot spot and you're looking to run air conditioning as well. So if you've got like a third story that gets very warm and you've got a window shaker up there, this is it's a much nicer cooling, and it's much nicer heating as well. Now down here in the tropics in Prince Edward County, this thing has worked like a champ all the way through the winter. The coldest night we had was around -20, but our average temperatures here are quite a bit warmer than Ottawa, but we had absolutely no issues. We were never close to having it being unable to heat the room. It was fantastic. And the cost for this one was about $9,000 for 2 heads. Right, so that's your brief summary of our household heat pumps. I guess we can open up for questions.
Yeah, and we've got quite a few, Matt. Thanks for that great presentation. You know, when you told me you were moving to Picton a couple of years ago, I didn't know you were going to be so inventive down there. So great work. Nice to see some of the stuff you've done. And yeah, we're getting quite a few questions and comments, trying to keep up with them. So I want to thank our member Chris Weisflog for jumping in on a few as well. But why don't we get started? I've got John V. He's just wondering, are there any 120V models available in the market too? Or he thought he heard that. Any?
I think, are you talking about for the dryers?
Yes, I believe so.
I think maybe the Mealy is 120 volts. You'd have to check.
Yeah, I think that was a general comment.
Yeah.
So Kevin was wondering, the Whirlpool was 50% more to buy. How much bigger was it in terms of physical clothing load size?
It's 4 cubic feet versus 7.4. So basically twice the size.
Great. Great, great, great. Nice to, a lot of stuff you can get in there.
Yeah, and this house was at one point a bed and breakfast, so it had full size. Although for two of us, we don't really need a full size washer and dryer. This is set up as a Airbnb, so I think it was done for that. It was convenient to do it for that reason as well, if you wanted to do that.
There you go. So you're saying after the pandemic, you're welcoming guests.
Yes, we are.
So Tanya Hewitt is wondering, how does a heat pump water heater compare with a tankless on-demand water heater?
Okay, so this is the dirty little secret. Tankless systems are not noticeably more energy efficient than a conventional gas one. The reason for that is that the energy loss through the tank itself is very small. The industry has sold tankless systems as being more efficient, and that's just not the case. They're more complex, they're more difficult to install, they take less room, but they don't really provide any reduction in gas usage or GHGs. So the cost of running a heat pump system compared with electric, it's about a third of the cost, and it's about 50% cheaper. No, sorry, not that much. It's about 20% cheaper than running gas. So it is actually cheaper than running gas. So it's a very
news.
Yeah, no, it's a phenomenal solution. If you have the panel space to do it, as we did, we upgraded our panel to do these projects, and it's a really good solution. And it's, if you've got a damp, accidentally heated basement like we do, it's a perfect solution.
Great. So Susan's wondering, how did the hot water heater reduce humidity in the basement?
Oh, it's an air conditioner, right? So the cold side is in the room, and the hot side is in the water. So the cold side actually pulls moisture out of the air, just like any other air conditioner, and sends it off through a pump to the drain. And it's phenomenal. I have a little thermometer down there I was using to monitor the humidity and the temperature in the basement while we were, after it had been running for a few weeks. I wanted to find out what it was doing. And the humidity down there was actually the same or slightly lower than the rest of the house. So it was really, really, really efficient at getting the moisture out.
That's great, especially in the summertime.
Keith? And running a dehumidifier is actually quite inefficient in terms of energy. So it's the same trick, right? It's just doing the same thing.
Exactly. Double dip on that. That's great.
Yeah, exactly.
So Keith is wondering, he's curious about the mixing valve on the water heater. Can you tell him which brand model you have? What is the temperature of the incoming water?
Oh, I don't know what brand it is. It was whatever Brad the plumber came with. It's a 3/4 inch tempering valve. They're very common. They're actually required by code these days. Although as a retrofit, I don't think you're required to put them on. I've set mine to about 50 degrees Celsius, and I run my tank at night at 60, and during the day I run it at 51. And so it doesn't matter what time of the day you use the system. You always turn the shower to the same spot, because the tempering valve always providing this hot water in the system is always delivering 50 degree hot water. It does the mixing for you. And obviously the other thing, if it's at 60 degrees, it's going to get mixed down quite a bit to get to 50. That actually expands the capacity of the hot water system by doing that. This is it. I have a 50-gallon system, and by running at 60, it's at 60 in the mornings when we have our showers, and that allows us to actually draw down more heat out of the hot water system than we would do without the tempering valve. So it's a good solution.
And Lucille's just wondering on the noise. Is it the heat pump unit? Is it inside or outside? And is it noisy wherever it is?
Are you talking? Well, I'll talk about the three things separately. So the one that we've actually on the screen at the moment, it's silent. You cannot hear it. The outdoor unit is utterly quiet, and the indoor unit, you see the vents on the bottom end of those vents make noises. So you can hear the little motors going as it adjusts itself, but you can't really hear the fan unless it's running on high. And so it's a phenomenally good system. So the outside noise pollution is minimal. It's below the legal requirement, which is 53 decibels. And if I would think it's probably below 40, I would guess. And the indoor unit's almost silent. I did have a problem at one point where the corner of the unit was vibrating a little bit, but that seems to have gone away. I think there must have been a bit of fluff in the fan or something. The hot water heater does make noise, and it's inside the house, so it's in the basement. It's if we go back there, there's a fan behind the hole here, and it's sort of a typical. It's the same sort of sound you get from the fan on an assisted gas, high efficiency gas system. It just runs longer. So we've actually got above it. Above it in the rafters, in the floor joists, we've put in Roxol wool to dampen down the noise, and that's worked fine actually. We've put in 2 bags of insulation in there, and it's covered quite a big area, and it's helped with the noise, and it's actually reduced the noise from the furnace as well. So it's quieter a lot quieter than the furnace, I should say.
Oh, that's great.
For a reference.
Yeah. You know, we've all got our noise canceling headphones, but there's only so much we can do with those, right?
So this house is a bit of a barn, and the roof, the floor of the main floor above this tank is just pine boards. So there's no sound isolation between the 2 floors at all. There are lots of spots where you can actually look down into the basement. So.
That's great. So we've got time for a few more questions, guys. I know they're coming fast and furious in chat. Thank you, everybody, for your engagement. I see quite a bit of activity there. Remember that at the end, if you didn't get a chance to ask your question or I didn't ask it, we'll get a chance to come on live and unmute you at the end after all the presentations, but we'll go through a few more here. So Mitchell's wondering, do you see a need for an auxiliary heating element for the heat pump somewhere like Ottawa that has colder winters?
I think I'll let Chris answer that one maybe afterwards. But yes, I would say if you do a whole house system, and we're going to talk about that in a minute with Rajan, you need some form of auxiliary heating. Yes. Now for what I'm doing here, I'm not bragging or anything, but I'm 440 degree days warmer than Ottawa. So on average, it's about 4 degrees C in the winter. Which is quite a big difference, and it actually puts for the system I have for the house heating, it almost eliminates the need completely. I don't think we'd ever get a day here that was cold enough that the efficiency would drop below 1. So, but in Ottawa, you've got Prince Edward County is not just warmer. I'm sticking out into Lake Ontario, so the variability in the winter is less as well. So Ottawa's a little bit different, and you can still get quite cold weather in Ottawa, which we don't get here.
And we've got someone who's wondering, they heard that heat pump dryers are much slower to dry clothes compared to conventional dryers. What's been your experience there?
There's a certain amount of truth in that, but it takes the same length of time as a washing machine. So why does it matter?
There you go. Yeah, so it's worth that extra little bit of a wait.
Yeah. So if you're doing laundry, you're doing 3 or 4 loads. Yeah, you just move it through as if you would do normally.
And Alex is wondering, what model did you buy for HWHP, and what other models did you look at? What were the electrical requirements
for the hot water tank?
Yes.
I only looked at Rheem because they're the only ones available easily in Canada, and this is the 50-gallon platinum something or other. It's basically the one that's available from Home Depot. They have it in 4 sizes. Raymond has the same system, but with a larger tank capacity. I think he's got an 80-gallon, but the same basic technology. We've both been very, very happy with them.
That's great. I've got one from Stefan. Could you explain the advantage of a 2-head heat pump versus the 1-head?
Oh, yeah, that's simple. Basically, you buy one outside unit, but it feeds 2 indoor units. So you don't have to hang. Aaron has got a fantastic slide about what happens when you have too many heat pumps in a building. Hopefully it's still in your deck, Aaron. But yeah, this means you have one outdoor unit that can feed. The outdoor unit I have will feed up to 4 units. So if you have a small house, you can actually do the entire house with a mini split. I think if I wanted to, I could do a mini split in my house in Ottawa and do away with the furnace completely. It would actually work quite well.
And Amy's just wondering about the size. She says, when you say the space for the water heater, do you mean that they need extra height? Or is it?
No, no, it just needs more free space around it for air circulation.
Okay.
And I think it's 100 square feet of floor space. Now, obviously, this is in my basement. My basement doesn't have any walls, so it's a lot bigger than that. But if you wanted to put it into if you have your hot water system in a closet, for example, you don't meet those requirements, and you have to duct the inlet and outlet air out, and there's a duct kit to do that. So you can. It's not a restriction. It just means that you have to. If you've got less space than that, you just have to bring the air in from another spot, or you have to vent the air out to a different spot, or you have to do both. But that's very easy to do. There are kits that fit on the vents to allow you to hook up to I think a 6-inch duct to allow you to move the heat and the cold away successfully.
Great. So
just installation detail.
We'll sort of wrap it at one more question. I see they're coming back through fast and furious. People are very interested. So we'll maybe invite Matt to jump on to chat there. And remember that at the end of the presentations, people will have a chance to come on. I tried to keep it kind of one question each. So the people who are kind of jumping in and asking multiple questions, you know, you've got a chance in chat there, or we'll have a bit of an opportunity at the end of the presentations to unmute people and have them come in. So Terry's wondering, as a final question here, is the mini split able to be combined with a hot water tank instead of having the hot water tank have a separate unit on top?
Oh, good question. I actually looked at a solution that would do that. It was crazy expensive. So between the mini split and the hot water system, I spent $12,000, I guess, to do it's called a hydronic system. And basically what happens is that the heat pump is all outside, and it delivers either hot water or cold water to the inside, or delivers both, which is a really clever trick that it can do. But those systems are much more expensive to have. Yeah, it'd be a nice idea if you could, if Mitsubishi made a indoor unit that hooked up to the hot water system. The issue is in the summer, the mini splits have to be all working in the same direction. They have to all be cooling or all be heating. So it'd be quite complex to have a system, you know, one part of the mini split always be heating to do hot water. But yeah, it would be a nice idea. Mitsubishi, if you're listening, please give it a go. You have the technology.
Absolutely.
Yeah, having the indoor unit in is in the summer, though, you're actually you're actively pulling heat out of the house, which is a good thing, right?
Yeah, it's going to be neat to see where the technology can kind of take some of these things. I had one more question kind of come through here that I wanted to touch on, and then we'll move on to Réjean's presentation. So Sanjay is just asking, are the fluids used in the heat pumps biodegradable?
Are you talking about the refrigerants? No. Oh, sorry, they're not biodegradable. They actually are sunlight degradable, though, and they're in accordance with the Montreal Convention. If you spend a bit more money, you can I don't think it's 134A in these devices. It's something related to it. It's a similar refrigerant. In fact, I know the mini split isn't, but it's not CO2. You spend a bit more money, you get to CO2, which has got no effect. So the issue with refrigerants is no longer that they damage the ozone layer. The Montreal Convention took care of that. But they do, the small amount of gas that you have in the air conditioning systems, and that's all of them, or your refrigerator, do have very, very high global warming potential. So if you own one of these devices and it's come to the end of its life, it's essential that you get the refrigerant pumped out before you dispose of it. But yeah, they're not particularly, the refrigerants in most of these units are not particularly climate friendly. So you have to follow the proper procedures to deal with the waste once you take them out of service. So that is a valid concern, but it's a relatively small amount of refrigerant in each unit, and I think overall the benefit is clearly to the good.
Well, thanks so much, Matt. Great to go through those questions. People obviously have a lot of technical questions. So, like I said, we'll have a bit of a time at the end. And want to thank Chris Weisflog and Art Hunter for jumping in there. And we'll save a bit of time at the end for them to jump on with some comments because they have a bit of experience with heat pumps and working with them. So we'll have that, and let's keep the conversation going in chat. Matt, just a reminder to unshare your screen there as we move on to Réjean, and yeah, let's bring in Réjean. So Réjean Plot is a retired senior planning consultant for the federal government. He's been retired for 4 years, lucky him, and graduated as an electronic engineering technologist in 1978. Well, that was a while ago. Studied in management and accounting over the years, so he became a planning advisor to middle and upper management for various departments. He's held director and president roles in 2 IM IT regional companies for about 10 years before retiring. He is an electric vehicle owner for the last 4 years, so good work, Réjean. And he's been a regional director of the AVEQ Outaouais. So thanks for your work there, Réjean, in bringing electric vehicles to people. And now we have to do the same with heat pumps. So over to you, Réjean, to share your screen and get rolling on your presentation.
Thank you very much, Nick. Thank you very much, Matthew, also for inviting me to share information about my system. Okay, that's the presentation. Got to switch to full screen here. Okay, so I will be talking about my system, and especially the decision selection process that I went through to choose it. I'll talk about the benefits of the system, and the advantages, of course, of having a heat pump system with the gas high efficiency system that I have. Let's get started. So what I had before the change, I made this change 1.5 years ago. I had an old 30-year-old furnace, which was not very efficient, probably down to about 70% after all that time. The metal chimney, of course, that comes with it, yearly maintenance contract with Gazify. It was 2-ton air conditioning system also attached to that. And of course, an old analog thermostat. So that's what I had as a starting point before my change. The new system, okay, what I ended up selecting was a Coleman Echelon gas furnace, which has a much higher efficiency, of course, as you can see, 98%. A new PVC exhaust pipe to the side of the home, so not using the old chimney anymore, just a different piping system. Came with a 10-year warranty, so there's no need for a maintenance contract for 10 years, which is great. It's a 2-ton Coleman Echelon heat pump. And it's, of course, I have a new HX, a programmable, remotely manageable thermostat. So that was definitely a plus, the thermostat that came with that. So here's what the system looks like. On the left, you see the thermostat. In the center is the external unit, of course. And on the right, you have the actual furnace. Pretty standard system, but it's a high efficiency one. The total cost of my system was almost $14,000, but it included a lot of stuff with it. The furnace, of course, the heat pump, thermostat, the piping, the conduits, the new electrical wiring system, breakers, installation, balancing, because they do have to do that work at the beginning to make sure it's fully operational at peak efficiency. It came with labor and parts warranty. I considered, of course, 3 configurations before choosing the one that I have for now. An electric forcer furnace with a heat pump, electric baseboard heaters, and a heat pump system, a high efficiency gas furnace and a heat pump, number C, which is what I ended up selecting. So in my analysis, the option A I found was very expensive. And of course, I would have had to upgrade my electrical panel from 100 amps to 200 amps. So that was a fairly important cost and a big change. Option B, which was the baseboard with a heater, was not very practical for us. We wanted to maintain a fan and like a system, a forcer system for the air conditioning system. we would have had to install a lot of new breakers and wiring through the house. So that was definitely a no for that one. And option C, we found it was the most cost-effective one. You have a 30% increase in efficiency with that brand new gas furnace. And of course, a heat pump would bring about 400% more efficiency than electric furnace or electric baseboard. But the choice was pretty clear, it was pretty obvious to go with that system for me. Operational cost reduction. So after a year and a half, we found that during the first year, we saved about $1,000 compared to what we paid on average for the years before that. We saved a lot on gas, of course, and the system is really, really nice. I'll put that on the next slide. We expect to recover the cost in about 14 years. It's a $14,000 system, so if you save $1,000 a year, that's pretty much recovering the money we spent on it. So we have environmental benefits, of course, by going with a system like that. The gas average yearly consumption for the previous system was 2,100 cubic meters of gas. With the new one, it's down to about 800 cubic meters. So that's a huge change. It's a significant emissions or reduction. What we found is that we have very good noise reduction with the system. The old system was quite noisy. The old furnace was noisy, and the external AC unit was even noisier. I have some dB measures there that I took before and after. So you can see the difference can be between 10 and 30 dBs, even 45 for the external unit. In the summertime, the unit is very, very quiet. In the springtime, in the autumn, when it's not too cold. When it gets colder and the system has to work hard, then there's a bit of a difference. And you can see it's a bit noisier because the heat pump, the compressor gets a bit noisy. So you have to select the right temperature, the best temperature, which is the most efficient for the system. I found that for my system, minus 6.6 degrees Celsius was a great place for the heat pump system to stop working if it gets colder than that. I tried different things. I looked at the noise. I looked at the how hard the compressor was working, and that seemed to be the best for me. We, of course, did get some home comfort benefits because the system comes with a variable speed fan, both for the furnace and for the heat pump compressor. So it adjusts itself all the time depending on the temperature, of course, outside. So that's where the noise can vary a lot. But when it's not too cold, you can see that it's extremely quiet. Before we had the change inside the house, we could really hear the air. Every time the system would start, it was like a big push, and you can hear the air in the air vents. But now with the new system, especially when the heat pump is the only one that's working, it's extremely quiet. We don't even hear the system when it starts or stops. So that makes a big difference for noise inside our home. And we also found that the temperature varies very little. And I guess that has to do with the new thermostat, electronic thermostat. So the system is on a lot of the time. It keeps the compressor very effective, and the temperature doesn't vary very much. So that's really nice to see. Other benefits, well, we found out that our neighbors really appreciate the difference, and they've actually told us so. We don't have to use the old chimney ducts anymore. They've been closed completely. The new furnace is much smaller, so it gives us more space in our furnace lounger room. We've been able to monitor and adjust the temperature remotely, pretty much from anywhere in the world. Wherever you have an internet connection, you can change the thermostat, the temperature. So that's really, really practical. If we happen to leave out of town, for example, and forgot to change the temperature according, then we can do it wherever we are. So that's really nice feature. That's pretty much it.
Thanks so much, Rajon. Great to hear about some of the stuff going on there and all the savings both in energy and obviously in dollars there for you. So great work on getting that up. And I do invite everybody to shoot some questions into chat there, and we'll have a bit of a general discussion. So Houston is wondering what percentage of your overall energy costs does $1,000 savings represent?
It's about a third to 40%, I would say. Trying to go from memory. Yeah, $1,000. Yeah, that would be maybe even more than that, maybe closer to 50%. Yeah, I would say.
That's great. Okay, I don't see any other questions. Houston says thanks. Thanks for being here, Houston. Oh, hang on, we've got a few trickling in here. So Stefan's wondering, what is the electric size of the heat pump?
The breaker is 30 amp. We also have a heater, electrical heater now instead of the old gas heater, and it's also 30 amp. So it's not a big breaker. So that means that the system runs below that. It's probably typically around 20 amps when it's running.
Yeah, one of the discussions that Rajan and I had early on was that this is the perfect solution for the 100 amp house.
Well, yeah, definitely.
Like it's the same size breaker as an air conditioning unit, so you already have AC. You can make this transition. And in fact, this should be required.
And of course, because we have an electric car, we have a charger, an electric charger for the car, which is 40 amps, and all that fits really nicely in our 100 amp panel.
So we've got Below 2C. So welcome Below 2C. Great job on your webinars. I've been following those quite a bit, and we'll talk about that a little bit at the end. So Below 2C is wondering how much of this cold winter does an outdoor heat pump fail to provide an efficiency advantage because it's so cold?
Well, actually, it's not all that cold all of the time. We do get some very cold nights, especially the night. That would make a big difference. By setting the heat pump at -6.6, it's running most of the time. The gas heater only kicks on at night, typically on a fairly warm winter day. If it's very cold, well, of course, the gas furnace will work more, but it doesn't take long that the heat pump kicks on during the day. We've installed our system on the south side of the house, so even if it's -12 degrees outside, it will still kick in at -6 degrees on the south side because the sun's on that side and it hits the side of the house and it bounces off and it's warmer on that side. So that helps a lot.
Great, so I've got a couple more questions. We'll maybe just get you to stop share there so everybody can see your face and see what's going on behind you there. So if you just get a chance to stop your share there. And we've got a couple more questions. So thanks so much. There we go. And we can see everybody and have a little bit of a Q&A there. So I've got Daniel Koch. Thank you so much, Daniel, for the question. Daniel's wondering, he's got a 50 amp system for his heat pump. So well done, Daniel. And 50 amp for the furnace portion. Okay, so that was just a comment. It wasn't so much a question. So well done, Daniel. Mitchell is wondering, what was the cost savings of this option compared to switching to an all-electric system?
The price was higher by probably $2,000 to $3,000. It would have been more expensive to run the electric furnace than the gas, the very efficient gas pump. And yeah, that's where there was some saving for sure.
Yeah, a whole house system, when I priced them out, has been about 20,000 for my house. Yeah, okay. For a whole house heat pump like Daniel's got. But you need to be able to allocate. In my house, it was 80 amps, I think, to the furnace to make it all work. So without 200 amp service, you can't even do it. But it would be more expensive.
Definitely.
So I've got one question. Just wondering where you live. You said Gatineau, right?
Yes, that's Gatineau.
So you've got that clean energy over in Quebec.
Right next to Ottawa, for those who might not be aware.
So Alex is wondering, is it best practice to treat heat pump solutions for house heating and hot water separate?
Ooh.
Well, go ahead, Matthew, you're the specialist.
Yeah, so I did some, as I said, I did some research on this. If you're going for a sort of a net zero house and you've got a super efficient house and you can get away with a small system, the hydronic heat pump systems that do both are incredibly efficient, and even more so if you go to ground source. So it depends on how much money you want to spend. Doing them separately is the cheapest way, and it gets you sort of 75–80% of the way there. If you can imagine, if we combined a Regent solution for heating where the backup is actually gas, and my hot water system, that's a long way towards reducing a lot of your emissions without having to go to a bigger panel. And I think that's in a lot of places in Ottawa in particular, the joys of working with Hydro Ottawa is that they don't like giving you more service, which is a bit weird. It's a real restriction, and being able to do stuff with 100 amps is a really, it's key if you want to do stuff now rather than waiting for 5 or 6 years when we're all going to get 200 amps.
That's great. So Dave Patterson's wondering, did the cost benefit account for the savings of the gas handling fees for a non-gas system? He's wondering, they're saying that's about $600 a year? Question mark.
It's not very expensive in gas. It's $10 a month, the basic fee that you have to pay. So that's typically what I pay from April to October, because I don't use any gas at all. So I just pay the base service fee for gas.
That's great. And David Anderson's wondering, does the system also provide you with hot water?
I have an electric hot water heater, so I switched from the gas one, but it's not a heat pump. It's just a straight, but it's a very efficient heating system. I didn't go for the low end, I went for the high end. So it's very efficient.
Right. Winifred is wondering, could a heat pump system replace a boiler?
Absolutely. Yeah, you can go with Arctic heat pumps out of Winnipeg, and they will supply you with everything you need.
That's great, man. Maybe throw that into chat for those people who are going to save that, because that's a great referral there. So awesome. We've got someone who wants to connect with you in Gatineau there, Regent. So you've already made friends here on Virtual Green Drinks. So double check the chat there. I've got a few more coming in here. So let's see. Let me grab those over here. Thanks for the questions, everybody, and nice to hear everybody's making some new friends there. That's what the Green Drinks community is all about.
I was going to say, I'm on Facebook too, so you can connect to me via Messenger. That's probably
there. You go. So I've got one saying, how would costs compare to retrofitting your home to passive house standards? If you have high energy levels of insulation, would you need very little heating and cooling?
Yeah, this is a tough one. With passive house, you can do, and Chris better unmute Chris at this point. If you can get right down to passive house, you essentially can do everything with baseboards and a small air conditioning unit. It's not required to go to these big solutions. My house is a barn. It's leaky. It's cold. It's got hot spots and cold spots. It was built in the 1800s, so it's not the most energy efficient thing. But yeah, you can do. Yeah, and as somebody says, Mitchell says, good luck converting an existing home to passive house. Yes, it's very, very difficult to do unless you sort of wrap the thing in a giant blanket. Yeah.
Yeah, absolutely. And we'll bring in Chris, remember Chris Weisflog from EcoGen Energy and Build. We're going to bring him at the end as well. So thanks for being here, Chris, and helping out with our chat. And we'll get him to pop in during our last half hour, say a few words about the work he's doing around passive homes and heat pumps. So I've got one more here from Tim, and Tim's wondering, why is it difficult to get a 200 amp service? Large-scale home renovators in Toronto are recommending to add 200 amp service when the home is under reno.
Oh, do you want my sorry story on this one?
We've got a bit of time.
Okay, so we have a house in Ottawa is a row house. That's the end unit of a row, it's an infill, built in 1998. Don't buy a house built in 1998 if you ever want to go to 200 amps, because you probably can't do it. Because it's a row house, we have a shared electrical cupboard on the end of the building. And that entire cupboard, which covers 9 houses, only has 230 amps available to it. So to get 200 amps into my house, I have to upgrade my panel. I have to update my feed, which goes underneath the house. I have to update the entire closet, which has got 9 meters in it, and I have to upgrade and they wanted to charge me for upgrading the transformer. Without the transformer, it was about $20,000 to do the project. To do the same with Hydro 1, it cost me just under $1,000 to get the new feed port bought in, and they credited me back $400. No, $600, 600. So it was $400 in the end, plus the panel, which was about 2,000. So it depends where you are on the infrastructure, but the infrastructure in downtown Ottawa is not built to get 200 amps to every house, unfortunately.
Okay, we've got one more from Sandra. She's saying, I may have missed it, but what is the square footage of the homes described?
Oh, mine, the house here is about 1,800 square feet. Rajan, what's yours?
Mine's about 1,800 square feet too. Three level basement and 2 floors.
Okay.
I say, well, we'll have to open it up for some tours once we get everyone with the vaccine there. So that's great. I know I'm going to be getting down to Picton and visiting Matt for sure. So thanks so much, everybody. Great conversations in chat. I want to thank Rajan for a great presentation and for all the hard work he's done on his home. So great work and way to blaze the trail, right? You know, 4 or 5 years ago when people were driving electric vehicles, you know, now it's the people who've got the heat pumps in their homes that are the early adopters, right? So well done there. So I do want to bring in for our last presentation, Aaron Thornell from CoEnergy and OREC. Many of you will know him. He's a bit of a regular on our green drinks. I know he's had a bit of technical issues, so let's just double check that he's still with us. Aaron, are you there? Should be good. He may have had to call in from his phone.
You may have to unmute him. Oh, there we go.
Coming in, Aaron?
How's that? Yeah.
Oh, there we go. There he is.
Sorry
welcome to Green Drinks. We have to get you a bit of a jacket made or something because you've been on a couple different editions with us. So thanks so much for all the hard work you're doing over there at CoEnergy. Excited to hear about what you guys are up to with your heat pumps. And let me know if you're able to share your screen.
Doing that now. And yeah, hopefully folks aren't sick of seeing my face.
Oh, never, Aaron. No.
Right. You're too kind, Nick.
And just a reminder, everybody, we'll have some time at the end to roll through some questions.
Sorry.
And if you do have any questions for Aaron, throw them into chat. I do have a bit of an intro here for you as well, Aaron, so let me grab that. So for those of you who don't know Aaron, I think there's probably maybe 2 or 3 on the call, but not many. He's the acting general manager over at the OREC Co-op and CoEnergy Cooperative. So these organizations seek to mobilize community capital to realize local sustainability projects, such as deep energy retrofits and solar installations. So through these parallel co-ops, they have financed and developed 8.5 million in carbon emission abating projects in Ottawa and Eastern Ontario. Well done, solely relying on member investments. So that's something that everybody can take pride in who's invested in that. Aaron is responsible for project development, member and investor relations, day-to-day administration, and a whole lot of other stuff. He's a firm believer of the cooperative model, and we're happy to have him back here for Green Drinks March. Take it away, Aaron.
Thanks, Nick. I was just wondering, are you able to unmute my my phone? It's a little
sure.
A little bit of delay.
Yeah, you're the 613 344?
447.
344 Okay, yeah, I see that one. Yep. So you should be good. So I think if you unmute now, you should be good. If not, we can. There you go.
Can you hear me?
Yeah, you want to mute your other line there, but you're good.
Yeah, I think I'm muted unless some people are feeling feedback.
No, I think you're good.
Great. Sorry about that, folks. It's joys of multiple people in the same apartment using Zoom for different meetings. But
we get it. We get it. There's lots of stuff going on.
the virtual world we live in. Wonderful to be with you folks tonight. I'll be honest with you, the depth of technical expertise that Rajan and Matthew just exhibited, you may not be getting that from me. We're going to be sort of talking a little more big picture, but for all you folks on the call who are, living in an apartment or a condo or a housing cooperative like myself, I'll be sort of talking to you folks, but definitely as Nick says, we do things by committee, by mobilizing community finance to realize these projects. So happy to talk about that. I'll speak to that a bit later. So, the reality is multi-unit residential buildings can be a tough nut to crack when we're talking about sort of the transfer to a low carbon, or zero carbon future. I was just on a design charrette for a new building, and even getting that to net zero electricity was a challenge for a multi-unit res, and it's even tougher when you're talking about existing buildings. And when it comes to dealing with heat pumps and heat pumps in these contexts, it can become very challenging. From our experience, and I'm happy to be proven wrong with experiences that folks on the call may have had, but it's been our experience that industry has focused less on multi-unit res and more on single family or small residential homes. I think largely that's a big part of just the industry maturing as a whole for heat pumps and the technology catching up. Certainly commercial buildings have maybe taken some important strides towards heat pump implementation. But there's complexity when it comes to multi-unit residential buildings. You've got high upfront capital costs. You've got lots of competing priorities for capital expenditures. Any of you folks who are, as I say, in a condo or in a housing co-op where those CapEx decisions are made by committee, there can be a lot of competing interests for that kind of expense. And comes with an extended payback in certain situations, and a lot of the focus historically on energy efficiency and electrification has focused on more shallow energy retrofits, the classic LED lighting example, maybe some water conservation, but we've yet to see really heat pumps take off in a big way in the multi-unit residential context. And then for those folks living in the rental market space, or and this applies to housing co-ops as well, that split incentive, wherein the tenants are going to be the ones reaping the cost saving benefit if they're paying their own utility bills, and savings are more difficult to recoup for the landlord or for the corporation that owns the property, who would be fronting the capital cost presumably. These are all challenges that that are sort of holding back this expansion to the MURB sector. Furthermore, I mentioned that decision-making hurdles. We've seen market penetration of only about 1.5% of all MURBs in Ontario implementing heat pumps throughout the building, and that's a dated number from 2018 from the Atmospheric Fund in Toronto. And I'd encourage anyone to check out the Atmospheric Fund's research on heat pumps. Incredible stuff they're doing in the GTA. Beyond this, you're dealing sometimes, and a lot of my work is dealing with property managers or maybe boards of housing cooperatives or condos that are maybe not as familiar with heat pumps. They're more familiar with the like-for-like replacement. This boiler's failing, we have to replace it. What can we do to get that done as soon as possible? Moving from something like a electric baseboard heated facility to a full heat pump system is something that maybe not that many folks in the property management sector are familiar with. I encourage folks to tune into the Greening Sacred Spaces webinar that's happening in a couple weeks. But from our experience, the incentive programs through the IESO for this kind of work have become quite scarce. Unfortunately, we don't want to get political here on green drinks, but I don't think it's a secret that the Ford government has maybe reduced the number of options available for incentives for this kind of work and others. With all that said, heat pumps really do bring a lot to multi-unit residential buildings. They really are a sort of jack of all trades. There are a surprisingly large number of electrically heated and cooled, MURBs in Ottawa. And when I say electrically cooled, I'm just talking about, electric-based, window shakers or window-mounted AC units. You know, we've all seen, you know, these pictures on the right where you've got windows open, but AC, you know, units presumably running during the summer months. And, you know, it's not, I don't think usually the fault of the tenant. It's lack of control maybe of their own heating and cooling systems inside their own homes. Not to mention the, you know, just general lack of efficiency that those window mounted units can have. You know, furthermore, in-suite electric baseboard. You know, I live in a housing co-op. You know, we've got a 6-story tower, all electrically baseboard heated in the suites, and it's a real challenge to control that heating system. It's a real challenge to, you know, not spend a ton of money using those kinds of heating systems. And so we really feel at Coenergy that this is a real opportunity. Heat pumps really bring a huge level of control, a huge opportunity for cost savings. And as, you know, folks are surely on this call aware, you know, Ottawa and some of the surrounding regions are, you know, slowly maybe shifting somewhat from a heating dominated environment to a cooling dominated environment. Now, it's not maybe as pronounced as areas down the, you know, down the 401 in Toronto, but, you know, we're seeing air conditioning as more of a need to have rather than a nice to have. And this becomes even more pronounced when we're talking about, you know, maybe seniors residences or, you know, low income or nonprofit housing, where folks maybe don't have the opportunity to install their own systems or don't have the opportunity to get out, you know, to the cottage or what have you to escape the heat. You know, we're seeing, you know, this air conditioning need be more and more pronounced. And as Matthew said, you know, anytime you're looking at air conditioning, you should be looking at a heat pump. And that's something we definitely believe very firmly at Coenergy. Furthermore, on the opportunity, just to quantify it a little bit, when we're talking about electric baseboard, you know, MERB buildings, and I apologize, I don't know what sort of scale of building this was speaking to, but, you know, we're seeing anywhere between 20 and 40% of cost savings on heating versus electric baseboard. And when you add to the fact that heat pumps consume roughly, you know, 5 times less energy than a window mounted AC unit, those two things combined really, you know, bring together a pretty nice economic package for multi-unit residential buildings to make the switch. The other nice thing about electric baseboard, as I think it was, you know, talked about a little bit before, is it can serve as a really nice backup heating source if and when needed. You know, again, we're dealing with, you know, potentially, you know, communities where buildings where, you know, maintenance services may not be, you know, coming at the drop of a hat, and so having a, you know, obviously a backup system in place is really important. Obviously, you know, the opportunities of economies of scale are something that folks are going to be familiar with when you're talking about, you know, a small MERB. You know, it's going to be a great opportunity to get a bunch of heat pump systems in there, you know, a bunch of indoor heads, fan coils, and service that. Beyond that, as you go bigger, you know, the bigger the building, usually the better the opportunity. But of course, there's, you know, a bit of a tipping point there. As I mentioned, increased tenant comfort. You know, I don't think this can be really, you know, can't be overstated. I think as important as, you know, all the environmental benefits that these bring, we're talking about, you know, sort of quality of life benefits when it comes to multi-unit residential buildings. And so I think that's a really, really important, you know, sort of aspect to bring in. And then of course there's, you know, the increasing electric demand. As we all know, electrification of everything is sort of the catchphrase of the day of late. And we know, you know, with electrification of transportation, you know, and other things, we're going to need to open up that capacity on the grid. And we at Coenergy and the Ottawa Renewable Energy Cooperative will do all we can to add solar to the generation mix. But ultimately, if we're going to, you know, meet the sort of demand, the electric demand that we think is coming, you know, we're going to need to be reducing demand within these multi-unit res buildings, and, you know, heat pumps, I think, are a great way to do so. So talking about the opportunities for actual uptake here, you know, there are certain programs that are coming through the province which are making, you know, energy benchmarking systems, the energy and water reporting and benchmarking program are starting to sort of spin, you know, sort of churn through their gears. They're working their way up from the sort of largest buildings and slowly working their way down to smaller facilities. Of course, these are not, I'm not sure if these are mandatory programs, and even if they are mandatory, there's no sort of consequences per se to, you know, if you've got a real lemon or a real energy hog of a building. But it's worth saying that the first thing you need to do is measure if you want to improve. And so the fact that these programs exist is certainly a step in the right direction. We've seen and have yet to maybe flush out this quantify this fully, but we've seen a real positive relation, anecdotally anyway, between property values and energy efficiency. So especially when we're talking about, a condo, property, for example, convincing your condo board to take on a heat pump retrofit is not only going to bring down maybe your annual condo fees if you're not, responsible for your own utility bills, but it's also going to bump up your property value down the line. Not only are you doing, the necessary asset renewal that's, sort of required and sort of part and parcel of living in a multi-unit res building, but beyond that, I think, and I'd love to hear from folks in the chat about this, I think there's more of an appetite and more of an interest for people to, be living in an energy efficient unit or home. And having a heat pump installed in there is sort of a really big ticket item that goes a long way to boosting that. There's the modular heating ability, that I think, has been talked about already. And yeah, I'm just repeating myself with the property value thing, so I'll jump into the innovation. And again, Matthew and Ray-Jean probably spoke more to the innovation and to the specifics of the technology that they've gotten in their homes. But the reality is we've seen really big strides in heat pumps. And I think, Matthew mentioned off the top that, this is not a new technology by any stretch of the imagination. Heat pumps, sort of have been around commercially, largely since, the 1980s, but we've really seen, pretty impressive strides in terms of their ability, especially in cold climates like Ottawa's, to service both in heating and cooling seasons. The Mitsubishi Zuba is sort of the known name on the market, going down to -25, -30 even. I've seen some of their spec sheets perform to that -25, -30 level. And so that's really alleviating, I think, a lot of concerns that a lot of folks maybe had historically, which is, I live in Ottawa, it's a cold environment. What am I going to do when we dip down below, -20, -25? Obviously, the reality of that is also that, we don't have that many days of -25 sort of ambient temperature. I think I spoke to a homeowner the other day who said he's only had about 72 hours in the last calendar year because, you're not dealing with wind chill, you're not dealing with all those things that draw our temperature down. But anyway, big strides there. The other thing that we've seen and we're really excited about at Coal Energy, and especially in the context of working with MERBs, is sort of these centralized condensing units. So these larger tonnage condensing units that can serve multiple units at once. The reason we're excited about this is the economics can often be better. The aesthetics for folks who care about that kind of thing can be better. You can sort of service these units, and if you're doing some maybe overcladding at the same time, we'll work on your building envelope insulation. You can hide those lines, those refrigerant lines behind the new cladding. Not to mention there's an increased ability for servicing and maintenance if and when necessary. So impressive to see these centralized units and sort of these systems being adopted from the commercial sector for the multi-unit residential sector is something that we're pretty excited about. I've already mentioned the modular heating ability a couple of times, but I think it just goes without saying, again, I've been in a few places during my early, university years where you just don't have the control you maybe like over your own unit's heating, and you end up wearing a t-shirt and shorts in the middle of winter because the landlord or the property manager has control over the radiators, and you just don't really get the chance to cool off or to sort of heat your building appropriately for the season. And for those of us who are, thinking about the environment, it can be a real painful experience. The other thing, of course, is the increased supplier competition and the effect that that's having on costs, which is really exciting. I wanted to touch quickly on ground source heat pumps. I know Art Hunter's in the call. He's the expert. He can probably jump in. This is the Eddy building, the Eddy condo on Wellington Street West, just across from our old office. And it's a condo with a ground source heat pump, which is really exciting. Developed by Windmill, a pretty progressive, environmentally conscious developer here in the city. and ground source heat pumps can be a really attractive option. I would suggest more attractive for new builds, maybe a little more challenging to make the economics work out in a retrofit context, especially if you're in a sort of highly densely populated and densely, sort of built up area. There can be challenges there, but we've seen, some pretty impressive examples. There can be some higher upfront costs, but I think I saw Art, mention a comment earlier, which was that, cost of operation is really, really impressive, really hard to compete with. So I would say ground source heat pumps are certainly on the table as far as, our cooperative is concerned and in the projects that we take on. But we just sort of put it out there to say maybe not the best fit for everyone. So I'm shifting gears a little bit away from sort of the technology overview and the context of MERBs and more towards like, how do we get this done, right? Because I think, we all, I think on the call are probably really passionate about seeing our sort of societies or cities or communities as a whole make this shift to a low carbon, a zero carbon future, an electrify everything future. And how do we pay for that? Because, obviously there's going to be financing options available. There's maybe, the odd, bank that might be out there who can help out a multi-unit residential building or, a real estate investment trust who maybe has, deep pockets and they can fund these kinds of things. Again, there's going to be maybe that split incentive thing that I talked about earlier, where the sort of savings are not maybe being passed on to the property owners without jacking up the rents. And there's all kinds of regulations and rules around that. So, from our perspective, it's all about how do we mobilize dollars from the community. I think folks can imagine the scale and scope of dollars within Canadian RRSPs or TFSAs. It's a lot of money. And when we think about how do we fund, this clean energy tech, or sort of renewable energy and clean energy shift, our firm belief is that we can do that with those dollars, with those RSP funds, with those TFSA funds, as well as just, investments from individuals. And this, lends, even more strength to these kinds of transitions, because there's folks in the community who get to benefit from them and get to see these kinds of projects happen. So as Nick mentioned, we've employed this model really successfully with solar energy here in Ontario, or excuse me, here in Ottawa. 21 solar projects, $8 million, all financed through our membership entirely. And so there's a real benefit. There's an amplified, local economic benefit to keeping those energy dollars local. And there's an ability maybe, where patient capital is available to undertake these projects. Properly is maybe a strong word that I use here, but sequencing them properly, that picture I showed at the beginning that had, 24 heat, condensing units on the side of a building, maybe that's not the best way to go about it. Maybe doing it sort of in a more of an, sort of engineered and thought out manner is going to help out. So just to speak a little bit more to co-energy, our focus is sustainability. First and foremost, our mandate is to accelerate the low carbon transition here in East Ontario and in West Quebec and the Outaouais region as well, and do so through the development and financing of renewable energy and energy efficiency projects. And what's unique about us, as opposed to, maybe some of the other kinds of groups that do similar things out there is, we're dealing with impact investments, but we're not dealing with, these large accredited investors, investing hundreds of thousands of dollars at a time. We're talking about an average of under $10,000 per investor over the course of the decade that we've been doing this. And, sort of employing the many hands makes light work in a sense, but, when we pool this with this impact capital, we can make a lot happen as communities. Beyond that, we're also cognizant that, as this shift is happening towards a clean energy, future, there's an opportunity for it to be a democratic or more democratic shift, where cooperatives like ours, which have, inherently democratic, governance structures, can have more of a say, can have more maybe control even of how we make this transition and ensure that the benefits of that transition are widespread. I think, there's been lots of stories about, over the pandemic, the rich have gotten richer. Crisis can often produce those kinds of, or amplify those kinds of inequities. And so, the climate crisis, sort of the looming shadow behind the COVID crisis in many respects. We want to make sure that is one where, we can play a small role in mitigating that kind of, increased inequity. When we were thinking about designing co-energy, we incorporated the cooperatives in 2018, thinking about heat pump retrofits was a really important piece to us because, again, maybe some drawn out, payback periods are patient. Our capital is what you consider patient. We're usually talking about 10 to 15-year investments for our members. And so, we're comfortable with those kinds of terms of payback. And so that's what often offers the opportunity for, for these kinds of projects to make economic sense. And I mentioned keeping the energy dollars local. It's really important. Folks may remember some studies from the energy evolution through the city of Ottawa over the last few years. The amount of money that leaves Ottawa on energy expenses is really, really astronomical. I think back in 2017-18, I think only about 5% of energy was produced locally. So we were looking to change that. So in terms of what our co-op does to do so, I've already sort of mentioned, so I won't dwell on this too long, but really it's about bringing, local capital to the table. It's about allowing collective action mechanisms to overcome decision-making hurdles. This is sort of speaking to, maybe your condo board or your co-op, housing co-op board, where, you can work with an organization like co-energy to sort of make these tricky energy decisions. I think a lot of these organizations are run sort of on a volunteer basis, maybe with support from property managers, but there's maybe not always that engineer or that electrical heat pump whiz, for example, on the board. So it can be challenging to make these kinds of large scale decisions that are going to have impacts in your building for 10, 15, 20 years. The other thing, and this is maybe most relevant to condo owners out there, is that there's sort of a two-pronged benefit. You can become a member of our co-op, invest in your own building's heat pump retrofit. You're earning those returns in the immediate term on your investment, and then you're earning the longer-term benefits like increased property value, like the more comfortable living environment and reduced utility costs down the line. So we like to think that's a little interesting sort of carrot for folks in the condo sector to think about when considering how to approach these kinds of large-scale retrofits. Focusing on overlooked sectors, I've already mentioned, MERBs generally have been an overlooked sector when it comes to heat pumps. Supporting decision-making, this is all something, sort of stuff that I've mentioned. And of course, we're not, looking at heat pumps in a silo. Implementing other measures in tandem can often really amplify in a positive way the savings potential of these retrofits. So whether it's pairing it with solar, with LED lighting, if that hasn't already been done, and or with building envelope upgrades and things like that, that's where the opportunities come for big time savings. And so we're always up for those kinds of complex and comprehensive retrofits. That's all I have for tonight. Thanks very much. I've seen the chat popping off. Happy to chat or answer some questions, Nick, if there are any.
Yeah, absolutely. Thanks so much, Aaron. We've definitely had a few come in here. So let me go through a few of these, and then we'll sort of open it up as a panel discussion there for everybody. I just want to reiterate too that we are recording this session. I've seen quite a bit of chat there. People have been asking me. We do record this. I'll get this out to everybody next week, and we've got all our past green drinks that I put into chat there. So everybody who maybe had to leave early, didn't get a chance to hop on time, you'll have a chance to watch the whole event again. So no problems there. So Aaron, Mitchell's, talking about cooling items as the bigger need is definitely something that I heard as well, and especially with condos and apartments. He's wondering how much of this should be led by individuals, and to what extent are property managers responsible for implementing a shared system for all unit owners?
Yeah, I think Mitchell, it's a great question, and certainly, to an extent, property managers are the quote-unquote gatekeepers of these kind of projects. But I think, especially if you've got a relatively receptive condo board, or, you're in a housing co-op where you're sort of one member, one vote, I think you can't underestimate the role that, an individual can have. And I think, as I mentioned, oftentimes it's maybe a lack of awareness of these kinds of solutions and the benefits that they can bring for the tenant that maybe, are the reason that these kinds of projects don't even happen, or don't even, the conversations aren't even started. And I think, property managers, I deal with a lot of great ones in the housing cooperative sector. They're running around from fire to fire usually, and maybe not as much time, to be able to devise a strategy to tackle a project like this. So if there's folks out there who have the energy and the time and a bit of the knowledge to be able to maybe start doing a bit of their research for their own building on their own, I would suggest that I would encourage them to do so. And get in touch with Co-Energy, because we can probably help maybe a little bit with that too.
Absolutely. So Alan is wondering, with a MERB, does it make sense to have a central system, or does each unit need its own heat pump?
Yeah, so it's a great question, Alan, and I think it kind of depends. Scale of the building is going to depend. Just availability of space is going to depend as well. Certainly, we've seen in a couple of instances that we've modeled and worked with, engineering firms on, or even, equipment suppliers on. There's times when centralized systems make sense. Now, you may be talking about maybe 4 or 5 condensing units that can be either located on the roof if it's a taller building, on the ground if it's sort of a spread out single-story or 2-story building. But there may be instances in which you do require a condensing unit per unit, per apartment, or per sort of suite. It's really going to depend on how easy it is to access through the walls to feed in the refrigerant piping, and all these kinds of things are going to play into those kinds of decisions. And of course, I mentioned the economics. That's going to be something that you're going to want to take into account as well.
So Alex is wondering, with the big focus on ESG and green bonds in the financial markets, do you think we'll see a stronger connection between this type of financing in the markets and the actual reduction in fossil fuel use by Canadians, i.e. heat pumps?
That's a great question, Alex. Yeah, great question. I think hopefully yes. Hopefully yes is my optimistic answer. But I think you need to be, and this is maybe getting off topic a little. I think you need to be cautious to an extent with ESG ratings and things like that when you're making your investments. Now, our shares through our cooperative are not held on the stock exchange, so we're a bit of a different category. But I think definitely it's there can be an association between the way that folks are investing and the actual tangible impacts. We like to think that it's really impactful to invest in projects that you can see and touch. Solar on your roof, heat pumping your building type thing. Whereas investments in other businesses on the stock exchange maybe are doing projects on the ground. Maybe they're doing more of other things. All that to say, I really do hope that we're moving in the right direction, and it goes without saying perhaps that I think it is a benefit that more folks are becoming aware of the carbon footprint of their investment portfolio. It's often a huge part of the individual's carbon footprint is where their investments lie, and so I think it's just a benefit. It's really a positive sign that more folks are thinking about this.
That's great. And I see a couple of questions for all the speakers, so we'll hold off on those guys, and we'll wait till the end to do a bit of a panel discussion. I've got some longer questions for people too, so what I'll maybe do is hold off and let people unmute themselves to get into the different projects that they want to do. So I'm seeing a ton of different projects out there, so we will have time to chat about that. I have one more for Aaron here. Aaron, Hannah is wondering, in terms of commercial buildings, 10,000 to 20,000 square feet that are not being used all the time, similar to faith buildings, is it cost effective to convert from gas to heat pumps? Maybe that's a bit technical for you.
Hannah, I think, and that's Hannah from Green Sacred Spaces, I think.
Hannah Morgan, yeah.
That for sure.
Okay.
But I think there could be an argument to be made there. might be tricky. I don't want to speak out of school here, but it's not a secret that here in Ontario we don't have the cheapest electricity compared to natural gas. That suppressed cost of natural gas is hard to compete with. But there's maybe ways to make that work. And what I would suggest, Hannah, is maybe say communities and other buildings of that nature could, there's looking at the heat pumps and the heating and cooling solutions and pairing that, as I mentioned earlier, pairing that with other measures. Whether it's windows insulation or envelope cladding, all these kinds of things. There may be arguments to be made there, but I think definitely we should chat and figure out how we can crack that nut for faith communities.
Great. Well, thanks so much, Aaron. Really appreciate your presentation. It was great to hear sort of the 30,000 foot perspective as far as pushing the heat pumps along, and important to consider how we're going to finance these projects, and important to consider also the cooling element too. So that's something that I got quite a bit from your presentation. So we have about a half hour left here. What I think we'll do here, guys, is we'll create a bit of a panel, and then people can kind of open up and ask any of the speakers. I want to add to our panel. I want to bring in Chris Weisflog. So Chris, you should be able to unmute yourself if you have a chance to come in. Chris is one of our members working in the heat pump space. He's a passive home builder and designer, and I'm not sure. Yeah, there he is. So come on in, Chris, say a few words. I know you've been quite active in chat there. So why don't you say a few words about what you're doing in the space, and then we'll maybe open up for some more questions to everyone.
Sure. So about 10 years ago, I got my certification as a residential HVAC designer. So whether that's hydronic heating or forced air heating, ventilation, those sorts of things. And then subsequent to that, I went and got certification in passive house design. And before that, before all those things, we were doing solar water heating, small residential and the commercial scale, including like the laboratory at Carleton University. Some of you may have seen that one there with seasonal thermal storage. And then PV design and build as well, so across the renewables, and ultimately bringing it all together into passive house, where we can make everything all electric, zero carbon, because that's really the remit all along, was always to get to zero carbon, helping people to live that way. So what's most applicable right now, I think, just generally speaking, if I can add a few points to what everyone else has said, is that, so we've been working with heat pump water heaters, very familiar with heat pump dryers or ventless dryers, those sorts of things, because those are the things we advocate for the houses that we build, as well as hydronic heat pumps and some experimental hydronic heat pumps as well. But also in general, most people are not in the situation where they're going to buy a passive house home. So I am sensitive to what most people are looking for here is the retrofit issue. And what I just wanted to say, where all this is concerned, is that the general approach to retrofitting should always be sort of three steps. It's, the first one is behavioral, and that is to decide not to do something. So that's maybe the negawatt, or it's basically turn the thermostat down or whatever if that's required. Second one is to go to efficiency, and that would be a passive efficiencies like the envelope. So making the envelope more energy efficient by more air tightening, better windows when that's cost effective, more insulation when that's cost effective. But all of these things that you do passively, and then active efficiencies like more efficient pumps, more efficient fans in your furnace, more efficient appliances, those sorts of things. And then lastly is generating energy like solar and that sort of thing. So that's the general approach. But more specifically, when it comes to the situation with HVAC, I just wanted to mention, as I did in one of the chat texts there, that the approach, you want to make sure that you get your envelope down as much as possible in terms of heat loss and heat gain. So those are active measures to reduce the heat loss, like insulation, air tightness, windows, whatever. But also to keep the sun out from overheating in the summertime, like shading devices and those sorts of things. And then what happens is that you don't need such a big heat pump, because the problem is that most of our homes are in the 80 to 100,000 BTU range, and they don't make really effective heat pumps that big. So if you can go from, say, an 80,000 BTU down to a 40,000 BTU home, then you can get a Mitsubishi Zuba that will do the entire job at minus 25 Celsius in Ottawa. Okay, I know we have a client whose house was about a 55,000 BTU. He got a 45,000 BTU system, and the house is just kicking into electric resistance once in a while. You know, or he just puts on the wood stove when it gets really cold. So the thing is, you can do it, but generally speaking, what you want to do is you want to attack the envelope first, because what it'll mean is, generally speaking, a smaller system, or it might put your house, which has existing ducts, it might put you in range where your heat pump is effective in that duct size. Because often, like with a furnace that burns natural gas, it can put out a really hot air, but heat pumps generally don't put out air quite so hot. So they need to move more CFMs, more air, for the same amount of heat. So, and ducts are limited by size. You can only move them so fast before they begin to make a lot of noise, or they take a lot of energy to move that air. So there's a limitation on your duct size. So there's a lot of reasons why it really makes a lot of sense with heat pumps if you're going there to, number one, reduce your heat demand by improving your envelope. And by doing that, you not only need a smaller heat pump system and put it within range of your duct capacities, but at the same time, you use less energy through, year over year. So there's a lot of reasons why that strategy makes a lot of sense. So envelope first, and then heat pumps. Okay, so I just wanted to make sure I said that. I mean, there's a lot of other specific things that came up and tons of notes I wouldn't mind mentioning, but we don't have all night, so I'm going to bite my tongue.
Yeah, well, we'll have to have you back for another session there, Chris. Thanks so much, and we'll have you stick around and maybe you know, have on our panel here when we go to do some questions. I also wanted to, if he's around, a heat pump system, ground source heat pump. Not sure if Art's there, so if he wants to jump in, I've made you co-host, Art, so you'll be able to unmute yourself. So at this point, let's start getting some questions from the audience. The easiest way for that, everybody, is if you can raise your hand with the reactions at the bottom screen, then I can go ahead and unmute you. If you can't find that reaction, then go ahead and hit me up in chat, and I'll try to find you and unmute you, or just raise your hand like this on the screen if your video is on, and I can unmute you. So who's got some questions? Looks like Mitchell's the first up, so let's unmute Mitchell for some questions. I know we had some other, Tim's got some exciting projects, Roger's got some exciting projects, so if you guys want to raise your hands there, you'll get into the queue. Let's go over to Mitchell now. Mitchell, you should be able to unmute yourself for your question. Go ahead. Well, maybe his Wi-Fi
yeah,
stalled.
I think I'm unmuted. Everybody can hear me, I would imagine.
Yeah, now you're good.
So I have a, can you guys, okay. I have an unusual, this and probably something that maybe Chris would be the best one to answer, but in terms of my house, I'm getting an energy assessment done next week because I need the energy assessment to be done for a variety of different and
Sorry, Mitchell, you're breaking up a little bit there.
You know that, but I have a particular that makes sense. Sorry?
You're breaking up a little bit there for it seems like you're good now. Yeah, maybe stop your video. There you go.
I'll take off my video, so maybe that's gonna help. Is that better?
Yes.
Yep, go ahead.
Okay. Yeah, so I was just talking about my attic space where I don't necessarily have a ton of room to add insulation, but whether or not there are options where you can focus insulation on other parts of the house to offset the fact that you can't put as much insulation into
Oh, and then we lost you again. Sorry about that, Mitchell. So we'll maybe get you to roll into chat, and maybe Chris Weisflog. I don't know if you want to share your email in chat. There's a ton of people who are looking for consulting things, so maybe it's a good place for people to start. I'll also share my email, so if people want to reach out to SmartNet Alliance with your projects. I know I've seen quite a few come through there. We can help you put you in the right place with the members. I want to go over to Art. Art, you should be able to unmute yourself now and come on in with a few words since you have one of these systems. Go ahead, Art.
Well, I guess I tried to jump in a number of places and make some comments, but the problem that I have is that I can't break this out just to being a heat pump, because I've done an integrated system, which means I've got solar and electric vehicle, Tesla batteries, and a ground source heat pump, plus a bunch of other things in between that makes one comprehensive energy platform. And just to talk about heat pumps as if it is a standalone unit, that's really hard for me, because I can't break costs out individually and performance out individually, not very well. But I can certainly talk about the entire system. And primarily, I was driven by the desire to have zero carbon footprint. I do not burn fossil fuels, either in the home for heating, cooling, hot water, or for transportation. So, and I've been doing this now for 4 years. As time goes on, I keep adding every year a little bit to the system. And the most recent one, of course, is to start adding some insulation and solar generating capacity on a vertical wall that's facing south. And this is an R&D project that I'm working with Roco Industries, which is a startup in Ottawa. And we're starting to get some good data from it now. And I expect that as we get to know what it's, how it operates, and some tweaking and design that was really interesting, and some assurance by the autumn when we have some good data. But at this time we're in the R&D mode, and I also make this known to anyone else who's interested in trying to integrate some clever technology into an. I'm quite willing to work with anyone who has any good ideas. Now, the other side of this coin is that people are always looking for what they might do in a retro. That's where I started, actually about 5 years ago, and where just about most of us do, and I wasn't quite sure what to do. But I went off and researched it and finally started doing a step-by-step approach to platform. It didn't happen all in one go, that's for sure. But one of the things that one has to think about is when you start doing this, you must make sure that you can do things in incremental steps, because you even when you borrow money, like I had to go and do some of this, that you have to look at what your cash flow is and what you can afford in cash flow, and as the paybacks start coming in, then you pay it off, and you pay it off at as fast a rate as possible. Anyway, what I'm quite happy to do is, if there are people who want to talk about, my journey, their journey, where are you, where do I go next, this is something that it certainly takes a whole bunch more than a couple of sound bites and things that happen in chat. And we might be able to arrange something else in terms of other Zoom conferences, because I certainly got a Zoom license, and we can put something together for 3 or 4 people if they want to do it one evening, and we'll just have a general chat about it all, because it's really quite interesting what all the possibilities are. I think somebody like Chris would be useful in that too, because he's really in the business of individual bits and pieces in the performance of the equipment, both in terms of, you know, how do you seal the place up and what you should do first. We heard his comments, and I thought everything he said, I certainly agreed with, even though I didn't do it that way. And I think we could have a very useful session just doing that without having to repeat the same thing time and time again. I'll just close out by saying one other thing, that prior to the pandemic, I was giving tours throughout the house, about 5 people at a time, because that's all I could fit in my control room. And of course, all that dried up, but I did 130 tours of about 5 people each. So, you know, roughly say 600 people have gone through, and some of them are on this conference right now. And I sure look forward to this pandemic being over, and we'll get more people coming through, because the whole idea was to demonstrate what is possible and to stimulate people's imaginations, because we've got this terrible climate issue that is bearing down on us, and if we want to survive, we got to do something, and I want to be part of that solution. Okay.
Thanks so much, Art. Yeah, it's great to great to hear about all the technology that you've employed over at your place, and it's quite a journey. I've been there myself. Pretty neat spot to go into your basement and see everything going on. So maybe if you want to share your email into chat there, Art, people can get a hold of you, and you guys can put that session together. And SmartNet Alliance, we're happy to support that as well. So we do have a couple questions, and I want to remind everyone, if you've got some questions, to raise your hands right now on the reactions at the bottom. That'll bring you to the top. I know Chris Weisfalk had a bit of a response to Mitchell's question, I think, regarding Enbridge and gas and things like that. So Chris, did you want to jump in, and then we'll move to Rachel, and then we've got Tim right after that.
Yeah, and that question that we had from Mitchell earlier, he was asking about his roof, not enough insulation, and what he should do. And that's a hard one to diagnose over the phone, sort of thing, or over Zoom. The best thing is to get an energy auditor in, and what the program is generally designed to do is to look at your house holistically and say you can get this amount of benefit by doing this much, let's just say on the roof, this much on the walls, or this much on the windows, this much on the basement, and then maybe attack the efficiency of the appliances as well beyond that. That's the traditional role of an energy auditor. The only thing I want to mention right now is that with the climate crisis, and the City of Ottawa has done their analysis, and they figure that homes need to, in general, get their energy footprint down by about 70%, 70%. That's a deep energy retrofit. And the only issue I have with all of that, or the biggest issue I have with all of that, is that you don't just do more of everything, because there's something that, in the Passive House community, because we do such high performance assemblies, that we're really savvy to, and that is the issue of movement of moisture and heat through assemblies. And they could lead to condensation of water in the middle of a wall, particularly if you have a vapor barrier on the inside, air leakage, and another vapor barrier somewhere else in that wall. And so you get condensation, mold, and mildew that could build up and over time destroy the wall. So the thing is that sometimes it's fine to go a little bit, but it may be really important to engage deep knowledge in order to go the distance for deep energy retrofits. So that's a caveat I would say with regard to these things. But back to his question about his roof. Sometimes you can add more insulation to a roof by adding another layer to your roof. So in other words, maybe strip all of the, there's a thing called the chainsaw retrofit, which was like remove your eaves and then add another layer on top and like seal up the whole envelope. And now your whole attic is now part of the insulated envelope. There's just different approaches out there. And that's where, that's why it's important to engage professionals to develop these options, not just the, you know, the carpenter down the street. Okay.
Thanks so much, Chris. Yeah, great response there. And yeah, no, it's great to have you as one of our members. And I want to thank Art for mentioning one of our other members, Rocco Industries. So I think Roderick put his website into chat there. But if there's some homeowners out there who don't necessarily want to do rooftop solar, but you want to dip your toes into solar, Rocco Industries is a great way to go because they have the solar siding that can go on the side of your house. So maybe people have told you, hey, you don't have the right roofs for solar, but now it's a bit of a game changer. So let's go over to Rachel. Rachel, we're going to unmute you here, and we'll go ahead with your question. You should be able to unmute. Thanks, Rachel.
Hi. So I recently bought a home, and there's a heat pump. There's radiant electric panels on the floor, even a couple baseboard heaters. And we've just been relying on the heat pump. I'm not really familiar with the whole idea that it gets less efficient the colder it gets. Maybe it's been a rather mild winter, and we've just been using the heat pump. But I'm wondering at what temperature, you know, might it be more efficient to use radiant panels, or how would I go about figuring that out?
So if you're just using radiant panels, if your heat pump's providing the heat you need, you're probably getting more out of those than you would out of just pure electricity. I suspect your first symptom would be the heat pump not making it rather than the efficiency.
Okay, so I guess I won't worry about it until it really gets cold in here.
Yeah, well.
I guess the other aspect of that also is the durability of the heat pump. If it's used a lot more, of course, if it's really cold, and it's not used much when it's warm. So if that compressor works very hard, maybe some of the specialists here could tell us if that makes a difference or not, if we should be concerned about it. My question.
Question for you, Rachel. Is the, when you say radiant panels, are they electric resistance radiant panels, or are they supplied by some sort of a heat pump?
I believe they're just electric.
Okay. Yeah, so the heat pump, generally speaking, depending on what year, you know, how old the technology is, and you have to look. Yeah, I know you probably don't know, and that's the thing is that you don't know whether it's a cold climate heat pump. In other words, extended range works down to -25 or whatever, or if it's just say a 15-year-old heat pump, which maybe worked down to -10 or -15. And then how efficient it is at a lower temperature, those sorts of things. Generally speaking, I would imagine that they would have some of their own internal cutoffs at which they just simply stop working because they're programmed not to work below a certain temperature. That logic should have been built into your system somehow, but I can't guarantee that. What I would suggest is try to dig up some tech lit on it and get to know it better. And then you would know whether to run it or not. But generally speaking, they'll run until they reach coefficients of performance or levels of efficiency of around about 1 point, you know, the low 1.54, something like that. After which they're not really worthwhile running because of defrost energy requirements and stuff like that. Another thing to note about heat pumps in general, especially air source heat pumps, is that when I mentioned earlier about a 45,000 BTU heat pump, a heat pump's output, that is how much heat it can give you, is also dependent on the air temperature on the outside. So, and also what air temperature you're trying to create on the inside. These are all relationships in the refrigerant and the system. So as the air temperature outside gets colder and colder, the amount of heat it can give you gets less when your house needs to put out more and more. So your house needs more to make up for what it's losing. So often they are sized with what installers call a toaster. which is an electric resistance element that goes into your ducts. So your cold air comes to the furnace where the heat pump is, and then it gets boosted up to the temperature that the heat pump can give it. And then the toaster will come on and boost it up to the rest. Now, a good sizing ratio that you typically hear is about 70% of the heat loss. So again, if I said your house was, say, a 50,000 BTU furnace required, then 70% would be 35,000 BTU out of the heat pump. And then your toaster would come on for the additional 15 when it's required, which sounds like a lot, but if you look at how often we're in the range when you need that extra 15, it's typically less than 10% of the time, and maybe closer to 5. So ultimately, about 10, maybe 10% of the total amount of energy will come from your toaster, probably less. So I don't know if that gives you some understanding of how air source heat pumps work and how the sizing of them is, but without knowing the specs of your unit, it's really hard to say when, whether you should deliberately turn it off or just let it run and it'll turn itself off if it can't help usefully.
Okay, I have seen the defrost setting come on the heat pump on some of our colder days. I guess when that is coming on, it might be a good idea to even just turn on some of the radiant panels so that it's not working by itself.
Well, the defrost cycle is natural for it to do in the wintertime, because even in the wintertime, there will get condensation outside, and that will freeze up and make it useless. So it has to defrost itself in order to continue to work. So just when it's doing that doesn't mean that it's not being efficient. It just means that it's doing something to maybe keep working.
Okay. All right. Thanks so much for answering my question.
Yeah, thanks, Chris. Great question, Rachel. Nice to hear you've got some practical experience there, and congrats on your first winter with a heat pump. We hope that more and more of us dabble our toes into that, and probably a good first winter to experiment. Not too many minus 30 days, right? So that's great. So also want to give a shout out to Sandra in the chat. Sandra's doing a whole book about an energy efficient home renovation. So head over to her website there and sign up. Sandra, I just signed up to the mailing list, so I'm excited to hear a bit more. And let's go over to Tim. Tim, you're going to be able to unmute yourself now and come on in with your question.
Okay. Okay. Thanks, Nick. Am I on? Okay.
Yeah, you're good. Thanks, Tim.
Okay, great. So I'm talking as a homeowner who wants to keep making it better. It's an old house built in 1895. Done some stuff. I'm also talking as an Ottawa citizen who really wants Ottawa to do a good job as a community, both the city and the corporation. Sorry, the city and the community. The rest of us guys and girls. So the group online here, you're all doing it. This is wonderful, and I'm getting so much out of that. And the city also has a small group, like a fairly small group of staff who are trying to enable all this within the city, and with heat pumps, particularly Janice Ashworth. My question is from a very cooperative point of view, like what are some maybe soundbite level things that the city could do most usefully? How can we most help the city to do what it needs to do to enable us? Or what can the city do most usefully to help us make it happen?
So maybe I can talk to that a little bit. The city itself is actually looking at PACE loans, which are loans tied to your taxes. So essentially your tax bill goes up, your loan, and you pay it off through your taxes. That is in progress, and that will be, I'm hoping that's going to be available this year. So the city is working on directly helping fund green renovations in the community, and that's going to happen this year. So the city is acting on that.
I just want to add that I was particularly taken by the city identifying the source for an R18 window. That really got my attention, and I'm sure it did almost everyone else who was on that last presentation that they made to us that you put together, Nick. That was really good, and I'm kind of looking forward to see what the city comes out with. And I got that NRCan link, and it says, hey, it's going to be retroactive to December 2020, which means if one wants to go after the $5,000 that is going to be made available, and you wanted to put R18 windows in, I mean, that makes a window, you know, as energy efficient as you know, a wall in some of the older buildings. And that is a great way to save energy. And I'm certainly looking at it, and I may well move on that now that I've got this NRCan link, find out what it's all about.
Yeah, absolutely. And we're working with the City of Ottawa on the rollout of their energy evolution plan. And, you know, it's quite a big plan. There's a lot of different pathways. You know, definitely bulk buying of heat pumps is something that they're looking into. So that could be something, you know, that's able to bring the costs down. And the Better Home Loan Program has officially been announced. So as to the launch, I think it is coming up. I can't give an exact date, but definitely stay tuned to SmartNet Alliance, because we'll be working hand in hand with the City of Ottawa to make sure all that information is out there and push that out to you. So if you're not already on our mailing list, there's a reason to get on right there. But yeah, no, it's great to see some of the stuff going on there. And, you know, we know that it has to happen. So, you know, we have to drive that. And that's what we're trying to do here at SmartNet Alliance, and by organizing events like this. So we do have time for maybe some last comments from everybody on the panel. Matt, did you want to jump in for some last comments?
Yeah, thank you guys for inviting us to do this. It's been an interesting conversation. I'm glad we've got everybody enthused on the new technology here. Well, not new, but a new old technology.
Thanks so much. Réjean, did you have any final comments? Anything you'd like to leave people with who are thinking about dipping their toes into the world of heat pumps? Oh, you're just on mute there, Réjean.
Okay.
There you go.
Well, I was just saying, I really just love my system. It's the savings I get from it, the noise level, which is so low now. It's really, really nice. I recommend it, of course, anybody who's running an older system and wants to move ahead and make the change. It's well worth it every which way you look at it.
Thanks so much, Réjean. I'm not sure if Aaron's still on the line. I think maybe he had to drop off. Chris Weisflog, did you have some final thoughts and comments if he's still on?
No, I'm just very enthused to see this crazy list of great questions and people who are very interested, and all the presentations tonight were really good. It's just nice to see such a groundswell of enthusiasm and movement forward. I know a lot of these guys also in the electric vehicle community, and clearly evangelists for a clean economy, a clean environment, and some of that social movement which was sorely lacking from 10 years ago. Although, having said that, I still see a lot of faces around the table on Zoom tonight who are the same people I saw 10 years ago. So awesome. So many of you who I'm seeing the faces of are the people who I'm actually looking at right now, who I used to see. So wonderful. Thanks, guys, for everything. And yeah, reach out. And I know I'm not really the consultant that some people are looking for, but what I'll do is I will make connections to who I think are the right people to help you if you reach out to me. So, anyway,
yeah, thanks so much, Chris. Really appreciate you coming in, and really some great work in chat, and you know, really great to have some of your input at the end here. Want to remind everybody that they can access the old green drinks. So we've been doing this virtually for 11 months now. So take a look at that. The last one was the Energy Evolution one, so that one's up online. Reminder, if you want to save the chat, all you have to do is hit the 3 little dots beside the file at the bottom right of your corner, and you can go ahead and save chat. So tons of stuff there. I know someone was asking for Art Hunter's contact. Someone was asking for Chris's contact. They've all put that in chat. So go ahead, everybody, and save chat, and I'll stay on a couple minutes at the end so people can do that. Joe, did you want to jump in for some comments? Joe Mulhall, the president of SmartNet Alliance.
No, really, I think you did a fabulous job, everyone, this evening. It's been very interesting and lots of interaction, great questions, great answers. It's great to be able to put these kinds of forums on, and the enthusiasm around Ottawa towards moving in these directions is terrific. So we're going to keep promoting the whole idea of sustainability and sustainable economy. And I heard some other voices along that line this evening, which is great. There's a lot of people going in the same direction. Let's just keep the momentum going. It's wonderful. Thanks.
Thanks, Joe. Yeah, it's great to see. We hit a bit of a high water mark today with about 130 people through the calls. So, you know, obviously there's a ton of interest in heat pumps. I want to say thank you again to all our panels, especially to Matt for putting this together, to Réjean and Aaron for your hard work, to Chris and Art for coming in and giving us some input and feedback and a lot of hard work in chat. I want to thank everybody for coming out tonight. It was one of those spring-like nights, so you had every excuse to maybe go outside or something, but nice to see a great crew. For next month, we're going to be turning our attention towards some organizations out there who are really fighting to make a difference. So we'll be kind of celebrating Earth Week, and in April we're going to have someone from the Good Choice Initiative is going to be along to talk about that. We've got someone from Time for Action, Kathleen and Ken, and Below 2C. They've been doing a great weekly webinar series. So they're going to be along to talk about the work that they're doing. And we've also got some folks from the Sustainable Eastern Ontario to talk about some of their work they're doing. So what I'll do is I'll email everyone next week with the link to sign up for that event, as well as the video from today. So if for some reason you wanted to watch it again, or you didn't get a chance to see the whole thing, you'll be able to see it on YouTube there. And once again, thanks so much. You know, we still have over 50 people on the call. So thanks so much, everybody, for your support. Keep following SmartNet Alliance. Keep coming out to the Green Drinks events. And I'll stay on the line for a couple of minutes so people can capture the chat. But what a great, fabulous night. A lot of learning and a lot of interesting perspectives. And we hope everybody's sizing up their homes for a heat pump now. Sounds like some great projects. So let's keep the conversations going, and let's move it towards the sustainable dial. Thanks again, everybody.
Nick, can I say one last thing?
Oh, sure. Jump in, Art, please.
Yeah, the one thing that was just touched on, Chris just touched on it, and that was geothermal storage of energy. And you got to look at energy as both heat energy and cool energy. And this is what I do as well. I store energy in the ground through the summer when I'm taking heat out of the house. I store it in the ground, and then I go and collect it again in the autumn to heat the house again. And I can store energy in the ground for between seasons without any problem whatsoever. I use the ground as a thermal battery, as well as I have Tesla batteries to store electricity, and the ground can be used to store energy as well. Anyway, I just wanted to leave that little thought for those people thinking about ground source heat pumps. They can be used in very interesting ways.
Yeah, absolutely. No, great points, Art. And, you know, it's quite inspirational to see some of the stuff you're doing. Sounds like I might get out there pretty soon to see, take some photos of Rocco Industries panels. So hopefully we'll see you soon to connect in a safe way.